Yesterday we learned about a type of sequence called an arithmetic sequence where we're adding or subtracting the same thing each time. Today we're going to talk about a type of sequence called a geometric sequence. A geometric sequence is where we are multiplying or dividing by the same thing each time, but we want to think about what are we multiplying by. So a geometric sequence is defined as a sequence where the ratio between consecutive terms is constant. So if I take one term and divide it by the term before it, that I get the same answer all the way through. Another way of thinking is that we're multiplying by the same thing each step along the way. Okay? That constant ratio that we have each time we're going to call R, and that's what we're multiplying by step to step. So yesterday we were looking at whether or not we were adding the same thing. Here we're going to look at whether or not we're multiplying by the same thing. So to get from 1 to 2, I need to multiply by 2. And then I multiply by 3, and then 4, and then 5. There's a pattern to what I'm multiplying by, but it's not the same thing. So this one is not geometric. To be geometric, we must be multiplying by the exact same number each step along the way. So to get from 81 to 27, what do I need to multiply by?
3.
I would divide by 3 because they're getting smaller. Dividing by 3 is the same thing as multiplying by 1/3. Works again, works again, works again. Okay, so each time here we're multiplying by 1/3. So this works, and our constant ratio is 1/3. Okay. Really, we can think of it as we're dividing by 3 each step of the way, but when it comes to our formulas, we want our ratio to be what we're multiplying by. So instead of thinking of dividing by 3, we're going to think of multiplying by 1/3. Questions? Okay, go ahead and decide on the next 2 problems whether or not they are geometric. All right, so does this one work?
Yes.
Yes. What are we multiplying by each time? -2. Each step along the way we can multiply by -2, and that would work out here. Does this one work? No. Every time we're multiplying by some kind of a 3, but here I multiply by 3, then I need to multiply by a -3. Then a 3, then a -3. So there's still a pattern to what we're multiplying by, but it's not exactly the same each step of the way. So this one is not geometric. So we have a formula that allows us to find a geometric rule. Back in our very first lesson, we talked about when we're multiplying by something over and over and over, our rule is going to have to do with exponents. And we can see that happen here in this rule. Like our formula yesterday, a sub n and n are variables. Okay? A sub n is some term in the list, and n is where is it in the list. A sub 1, just like yesterday, is not a variable. That means our first number in the list. And R is that common ratio. What are we multiplying by each step of the way? So for this one, it asks us to find the rule and then to find the 8th term. Okay, so that formula, just like the one from yesterday, does not need to be memorized. A sub n is a sub 1 r to the n minus 1, but you don't need to memorize that. I'll provide it for you when we come to the test on this. So to find our rule, a sub n is a variable. A sub 1 means the first term, that's -8. R is what we're multiplying by each step of the way. Sometimes it's kind of hard to see what we're multiplying by. What do I multiply an 8 by to make it into a 12? It's kind of a weird thing to think about because it's not a whole number. One way you can always find your ratio, and the reason why it's called a ratio, is if you divide your second term by your first term. That will give you your ratio. Or any pair of terms that are next to each other. So I could do 12 divided by 8, or I could do 18 divided by 12, or 27 divided by 18. But take 2 terms that are side by side and multiply divide the later one by the earlier one. Those both reduce by 4 to leave 3 halves. So that's our ratio. We're multiplying by 3 halves here. That is our rule. You cannot multiply the -8 times the 3 halves. Order of operations says we need to do parentheses, then we need to do exponents before we can multiply. And we can't do the exponent here because it's a variable. So you cannot multiply the negative 8 times the 3/2. Okay, so just leave it right there. Then we want to find what happens when we plug in an 8. We're asked for a sub 8, the 8th term. When you type this in the calculator, use parentheses as I have written them, and also either do 8 minus 1 in your head and type in a 7, or if you're actually going to type in 8 minus 1, then make sure you put parentheses around that 8 minus 1. I would just do the subtraction in my head there. I get negative 136.6875. Questions? Okay, this one is the same type of problem. Go ahead and try this one. Okay, so our formula is a sub n is a sub 1 times r to the n minus 1. We're going to let a sub n be our variable. A sub 1 means first number in the list, which is 5. R is the common ratio. It's what we're multiplying by each time. If you don't see what we're multiplying by, so how do I get from a 5 to a 2 is a little bit hard to think about, then we can always find our ratio by dividing the second term over the first term. So our ratio on this one is then 2/5. N is a variable, so we're just going to let it be n when we create our rule. We cannot multiply the 5 and the 2/5 and make it a 2. Okay, that will give different answers. Okay, order of operations, we have to take care of exponents before we're allowed to multiply. And we can't do our exponent because our exponent is a variable. Then we're asked to find the 8th term. That's what we get when we plug an 8 in for n. I would go ahead and just do that subtraction in my head and make it a 7, and then type this into the calculator. And we get 0.008192. Okay. And that's a good idea to always see if your answer makes some sense. So if I'm multiplying by 2/5, they should be getting smaller and smaller and smaller. If I'm already down to 0.32 by the 3rd term, then it makes sense that they would be pretty small by the time we get to that 8th term. This problem, once again, wants us to write a rule, but we're not given the beginning of the sequence here. We're given a term in the sequence. By giving us that term in the sequence, we've actually been given 2 pieces of information. We've been given that when n is equal to 3, a sub n is equal to 5. We're given a term down the line that when we plug in a 3 to our rule, we should get a 5 out. We don't know what the first term is, but our ratio, we're told, is 2. So up in that exponent, 3 minus 1 is 2, and 2 squared is then 4. So a sub 1 must be 5 divided by 4. Then we're going to take that a sub 1 and the r and write them into our rule. A sub 1 times r to the n minus 1. Questions? Okay, go ahead and try this similar problem. Okay, our rule is a sub n is a sub 1 times r to the n minus 1. Being given a term, we're given both the value of the term and we're given an n value. And we're also given an R value, but we don't know a sub 1. Up in the exponent, 4 minus 1 is 3, and 3 to the third power is 27. So then we divide both sides by 27, and a sub 1 is 1/9. So then we want to take that a sub 1 value and the given r value and plug them into our rule. 1/9 times 3 to the n minus 1. And that would allow us to find any term in this sequence. Questions? All right, so like our problems yesterday, we're progressing through again. In the first one, we were given everything we needed. We could find the r value by dividing. We were given our first term. Here we needed to find our first term. In this one, we're going to need to find the first term and the r value. To find our r value, what we want to do is these are supposed to be divisions. They're ratios. So we want to take the two terms that we're given and divide the later term by the earlier term. Always do the later divided by the earlier. So I'm going to do a sub 5 divided by a sub 2. And that gives negative 27. So that means to get from this second term to the fifth term, I would need to multiply by negative 27. But I'm not multiplying by negative 27 every step then. There's been 3 things that have been multiplied to accumulate to that. So our question is then, what do we multiply 3 times? The reason we're doing 3 is because 2 and 5 are a distance of 3 apart from each other. So what do I multiply by itself 3 times to get negative 27? Well, what kind of a symbol do we use for that question? So if we ask the question, what do we multiply 3 times to get something? What kind of a symbol is that? A cubed root. So what we're looking for is what number cubed, what number multiplied 3 times would be this. So what is the cubed root of negative 27? Negative 3. So negative 3 is what we must multiply each step of the way. There's a total multiplication of negative 27 between those terms, but something's been multiplied 3 times to make that negative 27. And negative 3 times negative 3 times negative 3 would give us negative 27. So that's our r value. So now this becomes like the last problem. And we want to use either one of the 2 points, whichever one you like the numbers for better, and plug them in. So I'm going to use the 45 with the 2. Two minus 1 is 1, so that negative 3 just stays a negative 3 then. And if I divide by it, a sub 1 is negative 15. Then we have all the information we need to write our rule. A sub n is negative 15 times negative 3 to the n minus 1. And once again, you cannot do anything about that negative 15 and negative 3. We can't multiply them together. We can't do like a double negative thing and make them both positive. It just has to stay just like it is. Questions? I'm going to go ahead and walk through this last one with you as well. To find our r value, what we want to look at is what is the total ratio between the 2 terms we know. So the later term is negative 1024 divided by the earlier term is negative 4. So we do that division out and we get 256. But we're not multiplying by 256 every time. We multiplied by something from 2 to 6 is a distance of 4. So we multiplied something 4 times to make a 256. So our question then is, what is the 4th root of 256? What do we multiply 4 times to get 256? And if you don't know it, you kind of guess and check. And you try it in your calculator. What do I need to multiply 4 times together to get 256? And that's 4. So that is our R value. So then we're ready to use our formula. And you can use either one of the 2 starting terms. It doesn't matter which of the 2 terms you use. I'm going to use the first one. So I'm going to have negative 4 is equal to, we still don't know a sub 1. We just found R is 4. And if I'm using negative 4, I need to use a 2 for n. I'm using this first point. 2 minus 1 is 1, so then that 4 just stays a 4. Divide by 4, and negative 1 is our first term. Then we take our first term and our R value and write our rule. Once again, we can't really do anything about that negative 1 and the 4. Just leave it hanging out just like it is. Don't try to simplify it at all because it's actually wrong to do so. I'm not just trying to save you work. It actually becomes wrong if you do so. Right? Right, your assignment tonight is from 11:3. Make sure you pay attention to your directions and do everything they ask. Also, in the first group of problems last night, they just said, is it arithmetic? And it was yes or no. Now tonight there's a little bit of an accumulation there. It says, is it arithmetic, geometric, or neither? So you want to check, are we adding the same thing each time? Are we multiplying by the same thing each time? Or is just something happening? Okay? So make sure you pay attention to those directions.